Okay, students, I hope you are all well and healthy and ready to learn new things. So, my name is Palak Patel. I am working in the Mahatma Gandhi Institute of Technical Education and Research Center, Navsari, in Civil Engineering Department. I am going to teach you the subject is Design of Structures. So, in this subject, we are going to learn continuous beam design. So, be ready and good luck. Here is an example which we discussed earlier lecture. Same example here. Same material, same property, same plan. And now we are going to design. Okay. Design a beam, continue beam. So first of all, we will design. In the previous lecture, we designed one-way slab and two-way slab. Both are continuous slab. And now in this lecture, we are going to design a beam. Beam number B80, B90. See where is B80? Here is B80. Sorry. B80, B90 and B20. So these three beams we have to design. Okay. First of all, we have to assume size of beam and size of column. We assume size of beam is 230 mm by 300 mm or 300 mm by 300 mm. So these are the size of beam and size of column. And then after we have to calculate load on a beam. So how many load on the beam? So on the beam we have slab load, then after masonry load, okay, and then self weight and live load. So these four types of beam. Okay. Now in the slab we have two more load. There is self weight of slab and floor finish, and most probably this live load is not directly applied on the beam. Live load is transferred from the slab. Okay, so we have to calculate these four type of load on the beam. Okay, and masonry load and self weight of beam we can calculate easily, but a slab load and live load, these both load are transfer from the slab. Okay, so we will understand how the load are transferred. So we have two types of slab. First is one-way slab. Okay, so here is a one-way slab. I am going to divide this slab between two parts. So here is a first slab and here is a second slab. So we have a two slab, and I am going to design a beam, this one. So slab load is transferred from one and slab transfer to load on the beam. Okay, and how this transfer? So we can discuss earlier, there is a one-way slab, it transfer a load in two directions. One-way slab, it transfer a load in two directions. Means is slab 1 is transfer a load only two direction. Okay, so in the on the slab we have only a slab load, one way continuous slab, one way slab. Yeah, our load we transfer it only on two beam. This beam is not carried a load. Okay, so how we calculate this? So look at here. I am going to divide a slab in the two parts. Okay. First is LX1, second is LX2. LX1 and LX2 is the short span short span of the slab. Okay, shorter span of the slab, LX1 and LX2. So let's start LX1 and LX2. So in the one-way continuous slab or a one-way slab, this slab 1 load is WLX by 2, WLX1 by 2, and the slab load 2, WLX2 by 2. So these are the two load which transfer from the slab to beam for the one-way continuous slab. Okay, and here is I am going to total load on the beam. Total load on the beam, which is W LX1 by 2 plus WLX2 by 2. Okay. These are the load which is transferred from the slab to beam. Okay. These are so simple one-way continuous slab. Let's go for the two-way continuous slab. So in the two-way continuous slab, load transfer mechanism say there is a load which is transferred in all direction, in all four direction. Okay, so in that case two-way continuous slab, load transfer mechanism will be here. This, and this is there is a trapezoidal which is at 45 degree. Okay, and here is LX1, here is LY1, here is LY2, here is LX2. Okay, so if I am going to design this beam, okay, so how many loads? There is a slab 1, here is a slab 2. So slab 1, here is a triangle. Okay, here is a triangle. So slab 1 load is WLX1 by 3, and slab 2 triangle shape WLX2 by 3. These are for what? These are for the triangle. Okay, so this equation which give a load which is transferred from the slab to beam in a triangle shape. Okay, and second is trapezoidal shape. Where is trapezoidal shape? Trapezoidal shape is at LY, means longer span, at a longer span. So at the LY there is a equation is W LX1 by 2 into 1 minus 1 upon 3 beta square. Okay, and where is beta is equal to Ly by Lx. Ly by Lx. These are the load transfer mechanism. I hope you understand very well. One-way continuous slab and two-way continuous slab. Load transfer from the slab to beam. Simply remember the equation, you can find out easily. Let's start the calculation. Load on the beam B80 and B20. First of all, we have to find out load on the slab. So on the slab we have the self weight of slab. 0.115 is the thickness into 25 density. So 2.875 kilonewton per meter square. Okay, and here is a 0.115 is a thickness of slab and 25 is a density of concrete. So self weight of slab is 2.875 kilonewton per meter square. These are the self weight of slab. Second is floor finish. So floor finish is given 1 kg per meter square. So here is a total dead load. Total dead load 3.875 kilonewton per meter square. This is total dead load. Now here is a live load 4 kilonewton per meter square. It's not useful. Okay, 4 kilonewton per meter square. It's a live load here. So 4 kilonewton per meter square live load is applied on the slab. Now we have to calculate dead load from slab. Dead load from slab. So from the slab we have the 3.875. It's a total dead load into 1.5 plus 1.5. 3.875. It's a total dead load. Total dead load into 1.5 plus 1.5. What is this? I will explain here. Okay, let's make a new whiteboard. Yeah, so here is a beam number 80 and 20. Beam number 80 and beam number 20. So I am going to calculate a dead slab load on the beam. Here is a here beam number 80. Okay, so what happened? Length 3 meter, here length 3 meter, here length 6 meter. So beam 80, our load is divided by this one way slab. So one way slab equation is W Lx1 by 2 plus W Lx2 by 2. Okay, so what is Lx1? Lx1 means here Lx2. I called it Lx1, I called it as Lx2. So W is the total load 3.8 on the slab into Lx1, so 3 by 2 plus 3.8 into 3 by 2. Okay, so I take a 3.8 in the column and 1.5 plus 1.5. So this is the equation. This is the equation. Okay, so here is 3.875 into 1.5 plus 1.5. So dead load from slab is 11.625 kilonewton per meter. Okay, dead load from slab 11.625 kilonewton per meter. Second, masonry wall. So for the masonry wall we need a thickness. We need a thickness of wall. So 0.150 is the thickness of wall, means I can say 150 mm thick wall. 150 mm thick wall. So masonry wall is 0.150 into 3.35 minus 0.3. 3.35 minus 0.3. So what happened here? 3.35. It's a total height 3.35. Sorry, 3.35. It's a total height between floor to floor. And here you can see here is a wall. Okay, it's a wall here. But we have upper the wall we have a one beam which thickness is 300 mm. So actual wall thickness, actual wall height is 3.35 minus 0.3. So this is called actual wall height. Okay, 3.35 minus 0.3 into 20. 20 is a density. Unit weight of wall. Unit weight of wall 9.50 kilonewton per meter. 9.50 kilonewton per meter masonry wall. Then after self weight of beam, 0.23 width of beam, 0.03 minus 0.115, minus 0.115 is a slab which we calculated earlier. So minus 115 is deducted from the 0.30 into 25. So value is 1.03. 1.03. So we have a 3 value here. First 11.62, second 9.50, and the third 1.06. Summation of all these 3 values, we got total dead load 21.83 kilonewton per meter. 21.83 kilonewton per meter. Now is the total dead load. We have to need a factor load. We need a factor load. So multiply by 1.5 into 21.835. So factor dead load is 32.75 kilonewton per meter. On these are the factor dead load on B80 and B20. Okay. So these are the factor dead load. Now we need a live load. 4 kilonewton per meter square, which is given. 4 kilonewton per meter square, which is given, into 1.5 plus 1.5. So total live load 12 kilonewton per meter, which is transferred from the slab to beam. From the slab to beam. So we got total live load, then we need a factor live load. 1.5 into 12 is equal to 18 kilonewton per meter. 18 kilonewton per meter. Understood? Here is a graph. Here is a drawing. This is load mechanism, you can see here. Okay, so these are the load mechanism on the beam 80, 90 and 20. We found dead load and live load on the beam 80, beam 18 and beam 20. Now we have to find out load on the beam number 90. Beam number 90. So from the beam number 90 we have to understand there is a two-way continuous slab on the beam 90. Okay, so load transfer mechanism will be changed here. So that load on the slab is almost same because there is no change on the thickness and no change in the floor finish load. So that load on the slab is 3.875 kN per meter square, which is dead load. Now we need equivalent UDL. So these are the 3.875. It's a total dead load on slab, and this load which is transferred in the beam number 19 by the equation WLX by 3, because it is multiplied by twice because there is a 2 slab which is load transfer on the beam number 90. So twice into WLX by 3. So equivalent twice into 3.875 into 4 divided by 3. So total dead load is 10.34 kN per meter. Okay, 10.34 kilonewton per meter. Same thing is masonry wall. Masonry wall weight is same 9.50 kg per meter. Self weight of beam 1.06 kg per meter. So total dead load is 20.55. Summation of all these three values. Okay. Then after factor dead load 1.5 into 20.55. 1.5 into 20.55. So factor dead load is 30.82 kilonewton per meter. 30.82 kilonewton per meter. These are the total factor dead load on the beam, which beam number is 19. Okay. Then after live load, equivalent live load twice into WLX by 3. Live load is 4. So 2 into 4 into 4 by 3. So equivalent live load is 10.66 kilonewton per meter. 10.66 kilonewton per meter. Then after factor live load 1.5 into 10.66. So factor live load is 16 kilonewton per meter. Okay, so now we have to go on the IS code, IS 456 2000, clause number 22.5. Sorry, clause number 22.4.1. Here is a clause number 22.4.1. Okay, so 22.4.1, what is say is a clause say arrangement of imposed load on a continuous beam. Arrangement of imposed load. So there is a two condition of arrangement of imposed load. There is a first is a design dead load on all spans with a full design imposed load on two adjacent span, and design dead load on all span with a full design imposed load on the alternate span. Okay, so what these two conditions say is, look at here. Here is a continuous beam. Here, and here is a second condition. Okay, so first say condition say there is a dead load on the all span, and live load is on the all span. That is called dead load plus live load. This is on the all span. And second condition say there is a dead load on all span but a live load on alternate span. So this is the first condition. Here is second condition. So these two conditions is given in the IS code. And the first say when design imposed load does not exceed 3/4 of design dead load. 3/4 of design dead load. When design imposed load means a live load. Imposed load means a live load is not exceed, means it's not greater than 3/4 of dead load. 3/4 of dead load. 3/4 of dead load means 0.75 dead load. So at this condition, when this condition fulfill, the load arrangement may be design dead load and design imposed load on all the span. On all the span. Okay, so means this condition when fulfilled, we assume there is dead load and live load at on the all span. So right now we are going to calculate 0.75 dead load. 0.75 into 32.75. 32.75 is the dead load on beam 80 and B20. Okay, so 0.75 into 32.75, so load is 24.56 kilonewton per meter. 24.56 kilonewton per meter, and we have a live load value is 80 18 sorry live load value is 18 okay, which is lesser than 24.56. so our condition is fulfilled. So when this condition fulfill, our dead load plus live load at all span. Okay, so here is live load less than 0.75 dead load. So load arrangement may be designed dead load plus live load on all span. There is no different load cases are required. Okay, this condition is fulfilled. So we have to dead load plus live load on all the span. So we not need a different load cases is required. So all span we have to follow dead load plus live load. So on the span AB 15.75 kN per meter square, this is dead load plus live load. 46.82, here is dead load plus live load, and 50.75 is same dead load plus live load. So these are the 50.75 UDL load is applied on the beam A and B. 46.82 kN per meter load which is applied on beam B and C, and 50.75 kN per meter load is applied on C and D. Okay. Okay students, so I am going to try to cover one topic or continuous beam in this lecture, but this topic is too lengthy for the understand and learn, so it will take a more lecture, more than a 2 or 3 lecture. So this is the first part of the continuous beam is completed, so be ready for the second part. Take care and